Today we confront a paradox. The rules of math seem to be a pure invention of the human mind, and yet they describe the universe with impossible precision. So which is it? Is mathematics discovered or is it invented? This is a question that has bothered me for a very long time. It is a puzzle that does not seem to have a rightful place in the filing cabinet of science. You look at the world around us, this messy, complicated jumble of things. There are trees that wiggle in the wind, water that splashes, clouds that drift apart. It looks chaotic. It looks like a whole lot of distinct individual stuff just doing whatever it wants. But then you go into a quiet room, you sit down with a blank sheet of paper, you close your eyes and you forget about the trees and the wind. You start to play a game in your head, a game of logic. You invent some rules. You say, let there be a triangle. You say, let a squared plus b squared equals c squared. You make up symbols. You create a language called mathematics. It is a pure invention of the human mind, just like the rules of chess or the notes of a melody. It does not have to exist anywhere outside of your brain. But here's the miracle. Here's the thing that stops me in my tracks. If you take those scribbles, those invented rules from your head, and you apply them to the real world, they work. And they do not just kind of work, they work to a terrifying degree of precision. We can take a piece of paper and calculate the magnetic behavior of an electron, a little particle you cannot even see, and our invented numbers will predict the result of an experiment to 12 decimal places. That is like measuring the distance from here to the moon, and being accurate, to within the width of a single human hair. How is that possible? How can a game we invented in our heads describe the behavior of a universe that was here billions of years before we were born? So this brings us to the great mystery, the deep question we are going to explore today. Is mathematics something we invent, like a story, or is it something we discover, like a continent? Did we build the keys to the universe, or did we just find them lying in the dirt? Because if math is invented, it should not work this well. And if it is discovered, well, then what exactly is it? Where does it live? We are going to try to pull this onion apart, layer by layer. All right, let us look at the first possibility. Let us look at the idea that we made the whole thing up, that mathematics is an invention. Now, when I say invention, I do not mean it is a lie. I mean it is a creation, like a symphony or a game of chess. Think about it this way. You go out into the street and you find stones. You find 3 stones. You find 3 apples. You find 3 people. But you never find a 3. You never trip over a number 3 lying on the sidewalk. You can hold 3 stones in your hand, but you cannot hold the concept of 3. 3 is an idea. It is a label we stick on things. It is an abstraction. And abstractions are things that human brains produce. They do not grow on trees. So, we start with these symbols. We scratch them on a cave wall or a blackboard. Then we make rules. We say, if I have this symbol and I add it to that symbol, I get a new symbol. We invent the grammar. We invent the axioms. Consider the game of chess. This is the perfect analogy. Who decided that the knight, the little horse piece, moves in an L shape? Did we find that written in the stars? Did we dig it up in a mine? No. Some guys in India or Persia a long time ago just decided it. They said, let us make the horse jump like this, and let us make the bishop move diagonally. It is an arbitrary rule. It is a human invention. Now, once you invent the rule, you're stuck with the consequences. If the knight moves in an L and the bishop moves diagonally, then it turns out, whether you like it or not, that you can force a checkmate in a certain number of moves. You did not invent the checkmate. The checkmate is a consequence of the rules you invented. But the game itself, that came from us. And mathematics is just a very, very elaborate game of chess. We can see this is true because we can change the rules. Look at geometry. For 2,000 years, everybody listened to Euclid. Euclid laid down the law. He said parallel lines never meet. That was his rule, his axiom. And we built our houses and our bridges based on that rule. It works fine on a flat piece of paper. But then in the 19th century, some mathematicians got curious. They said, wait a minute, who says parallel lines cannot meet? What if we change the rules of the game? So they invented a new geometry where parallel lines do meet. Imagine drawing lines on a basketball. If you start at the equator and draw two lines going straight north, they are parallel at the start, but they crash into each other at the North Pole. Suddenly you have a non-Euclidean geometry. You have a whole new system of math. Now ask yourself, if math was already out there waiting to be discovered, how could we have two different geometries that contradict each other? It is because we are the ones writing the book. We are the tailor. We can stitch a suit with 2 arms, or we can stitch a suit with 7 arms. We can invent 11-dimensional spaces. We can invent number systems where 1 + 1 = 0. We can do whatever we want, as long as we are consistent with our own rules. So from this point of view, mathematics is the greatest creative fiction ever written. It is a glorious playground of the human mind, unfettered by reality. We build the castles, we dig the moats, and we define the laws of the kingdom. There is always a but if this is just a game we made up in our heads. Why does the bridge stay up? Why does this invented language describe the curve of a falling ball so perfectly that we can bet our lives on it? If we are just making up the rules like we do in chess, why does the universe seem to be playing along? Now hold on a minute, put the brakes on. If mathematics is just a game of chess, if it is just a set of arbitrary rules we cooked up in our heads, then we have a very serious problem, because if we just made it up, nature should not care about it. The universe should not pay any attention to our little game. But she does. You go out into the garden, you look at a simple thing, a pine cone or the head of a sunflower. You look closely at the way the seeds are packed. They spiral. And if you take the time to count those spirals, count the ones going left and count the ones going right, you find something that makes you shiver. You find numbers. You find 8 and 13, or 13 and 21, or 34 and 55. These are not random numbers. These are specific integers from the Fibonacci sequence, where every number is the sum of the 2 before it. It is a precise mathematical progression to. Now you have to ask yourself, did the sunflower go to high school? Did the pine cone study arithmetic? Of course not. The plant is just trying to do a job. It is trying to pack its seeds as tightly as possible to survive. It is biology. But the way nature solved that problem, the most efficient way, just happens to be this precise mathematical sequence. The math was already there, doing the work, long before we humans ever wrote down a plus sign or look at something bigger. Look at gravity. Isaac Newton sits down and writes a law. He says the force of gravity drops off with the square of the distance, the inverse square law. That means if you go twice as far away, the pull is 1/4 as strong, not 1/3, not 1/5, 1/4. The exponent is exactly 2. Now that is strange. Why is it exactly 2? Why is it not 2.000001? Why is it not 1.99999? If we invented the math, we could have made it anything. But we did not get to choose. We measured the moon, we measured the falling apple, and we found that nature is rigid. She has a rule book. She follows that too with a precision that is terrifying. And here is the example that really gets me. It is the story of the ellipse. 2,000 years ago, the Greek mathematicians were playing games with shapes. They took a cone, like an ice cream cone, and they sliced it. They looked at the curves you get when you slice a cone. Circles, ellipses, parabolas, hyperbolas. They studied them just for the beauty of it. Pure invention, pure abstraction. They thought it had absolutely nothing to do with the real world. It was art. Fast forward 2,000 years, Johannes Kepler is looking at the data for the planet Mars. He's trying to figure out how it moves around the sun. He tries circles. It does not work. He tries complicated loops. It does not work. And then he tries the ellipse, that old shape the Greeks played with, and snap, it fits perfectly. The planet Mars has been tracing an ellipse in the darkness of space for billions of years. The planet does not have a pencil. It does not have a piece of string. It does not know geometry. And yet it follows the path of an ellipse so accurately that we can predict where it will be 100 years from now. So in this view, we are not inventors at all. We are explorers. We are like archaeologists. We are digging in the dirt of reality, brushing away the dust, and finding these beautiful, hard, mathematical structures that were already there. We did not build the pyramid, we just found it buried in the sand. So patterns exist, the relationships exist, we just give them names. But this leads to a terrible conflict, a friction, because if we invent the language, but we discover the story, how do we know our language is the right one to tell the story? How do we know our map matches the territory? So we have a fight on our hands. In one corner, we have the symbols, the x's, the y's, the integrals, which are clearly inventions of the human mind. In the other corner, we have the planets and the atoms, which are clearly doing something precise that was there long before we showed up. And how do we reconcile it? I think the best way to look at it is the distinction between the map and the territory. You see, mathematics is the map. Reality is the territory. Suppose you want to describe where a specific atom is in this room. You have to invent a system to do it. You might say, okay, let us make the corner of the room 0. Let us measure 3 feet out, 4 feet up, and 2 feet across. That is a Cartesian coordinate system, a grid. Now ask yourself, is there a grid in the room? If you look with a microscope, do you see little blue lines floating in the air marking the inches? Of course not. The grid is in your head. The grid is an invention. You could have chosen the center of the room as 0. You could have used spherical coordinates, an angle and a distance. You could have measured in meters instead of feet. The universe does not care. The atom is where the atom is. It does not know about your 0 point. It does not know about your x-axis. So the description is arbitrary. The description is invented. But, and this is the big point, the relationship between the points is not arbitrary. If the atom moves from here to there, the distance traveled is real. It does not matter if you calculate it in feet, meters, or cubits. The physical reality of that distance remains the same. The map can be drawn in red ink or blue ink, but the mountain it describes is made of rock. This is where it gets really interesting for a physicist, because it turns out we can invent 2 completely different mathematical maps to describe the exact same thing. Take the motion of a falling ball. You can use Newton's laws. Force equals mass times acceleration. You calculate the forces, you integrate step by step, and you get the path. It is a causal description. The ball moves because a force is pulling it right now. But there is another way, a completely different invention called the principle of least action. You do not look at the forces, you look at the energy, kinetic and potential, and you say, the ball will take the path that minimizes the difference between these energies over time. It sounds like magic. It sounds like the ball knows where it is going before it gets there, and the math looks totally different. The equations are different. The philosophical implications are different. But guess what? Both maps lead you to the exact same spot. If you calculate the trajectory with Newton and you calculate it with least action, you get the same answer. This tells us something profound. It tells us that the mathematics is a tool. It is a pair of glasses we put on to see the world. We can change the glasses. We can polish the lenses. We can invent new frames. But the light coming through them, that is the discovery. So the interface is this. We invent the language, the grammar, the symbols, the coordinate systems, but we discover the logic that connects them. We discover that no matter which map we draw, if it is a good map, it leads us to the same hidden treasure. But this brings up a very strange question, a question that really makes you wonder about the architecture of the universe. If we can invent any map we want, why do some maps work so miraculously well, while others fail completely? Why does the universe seem to prefer certain kinds of mathematics? Why, when we invent a strange little game with imaginary numbers, does nature suddenly say, yes, that is exactly the language I was waiting for you to speak? Now, I want to talk to you about something that I find absolutely miraculous, and I do not use that word lightly. In science, we do not usually talk about miracles. We talk about laws, but this is spooky. We said earlier that we invent mathematical games. We make up rules for fun. Sometimes mathematicians play these games just to see if they can solve a puzzle. They have no intention of describing the real world. They are just doodling in the margins of logic. Take, for example, the square root of -1. Now, you know, basic arithmetic, you know that if you take a positive number, say 2, and square it, you get 4. If you take a negative number, minus 2, and square it, you also get positive 4. Minus times minus is plus. Everyone knows that. So some mathematicians ask the silly question, what number, when squared, gives you minus 1? In the real world of apples and stones, the answer is nothing. It does not exist. It's impossible. But mathematicians, being the stubborn people they are, said, let us pretend it does exist. Let us call it I for imaginary. Let us invent a whole system of numbers based on this fake, impossible thing. And they did. They built a beautiful structure called complex analysis. It was a masterpiece of pure thought, but everybody knew it was just a game. It had nothing to do with the real world because you cannot have eye apples. But then the 20th century arrives and we start looking at the atom. We start looking at electrons. We try to figure out how they move. We try to write down the law of motion for the fundamental particles of the universe. And Schrödinger writes down his equation. And there, staring us in the face, right at the beginning of the equation, is that little letter I. It turns out you cannot describe the motion of an electron without the square root of minus 1. The wave function, the very thing that tells us where matter is a complex number. It has a real part and an imaginary part. Nature is using our fake numbers. How did that happen? We invented a toy in the 16th century just to solve a puzzle on paper, and it turns out to be the fundamental language of the quantum universe. It is as if you were sitting in a dungeon completely cut off from the outside world, and just to pass the time you carved a strange jagged key out of a bar of soap. You just made up the shape. I will put a bump here, a notch there, pure invention. Then one day, you'll find a heavy iron door you have never seen before. You stick your soap key into the lock and click. The door opens. Why does the key we carved in our heads fit the lock of the universe? And it is not just imaginary numbers. It happens over and over again. Look at symmetry. Mathematicians studied group theory, the study of rotating shapes, just for the elegance of it. It was abstract art. Then physics comes along and we find that the secret to the elementary particles, quarks, leptons, baryons, is exactly this: group theory. We found that the universe is built on symmetries. Murray Gell-Mann predicted the existence of a particle, the omega minus, not because he saw it, but because there was a hole in the mathematical pattern. He said, the math says a chair is missing here, so a particle must be sitting in it. They looked, and there it was. This is the unreasonable effectiveness of mathematics. It is a mystery that goes deep. It suggests that the structure of our minds, the logic we use to invent these games, is somehow tuned to the same frequency as the structure of reality. You're not just imposing order on the world. The world is ordered, and it seems to be ordered in the same language that we speak. But this leads to a dangerous thought. It was a very dangerous thought. If our invented math works so well, does that mean the math is the only thing that is real? Are we just living inside a giant equation? Or is it that we are just very good at finding the tools that work and we throw away the ones that do not? Is this a miracle, or is it just survival of the fittest? Now, before we get too carried away with this miracle, let us put our feet back on the ground. We can sit here all day and invent beautiful mathematical systems. We can invent a geometry where triangles have 500 degrees. We can invent a logic where cause comes after effect. We can invent a universe with 17 dimensions. But here's the catch. Here is the brutal truth of science. Nature is the judge. She sits there with a gavel, and she is a very tough judge. You can come to her with your beautiful, elegant equations. You can say, look, nature, look at this math. It is perfect. It is symmetrical. It is logical. And nature will look at you and say, I do not care. If your math disagrees with the experiment, it is wrong. And that simple statement is the key to science. It does not matter how smart you are, who made the guess, or what his name is. If it disagrees with the experiment, it is wrong. That is all there is to it. Let me give you a famous example. For 300 years, we thought the universe ran on Euclidean geometry. You know, the geometry you learned in high school Flat space, parallel lines never meet. The angles of a triangle add up to 180 degrees. Isaac Newton built his entire theory of gravity on this stage. And it worked. It worked for the falling apple. It worked for the cannonball. It worked for the moon. It was fantastic. We thought we had discovered the truth with a capital T. But then we started looking closer. We looked at the planet Mercury. It was wobbling just a tiny bit too much. It was not following the path that Newton's math predicted. It was off by a fraction of a degree per century. Then we looked at light passing near the sun. According to Euclid and Newton, light should go straight. But Einstein said, "No, I think the math is wrong. I think the stage itself is bent." Einstein reached into the dusty shelf of mathematics and pulled out a different tool. He pulled out Riemannian geometry, non-Euclidean geometry, a math where space is curved, where parallel lines can meet, and where triangles do not add up to 180 degrees. And you know what happened? He applied this weird math to the universe, and suddenly the wobble of Mercury made sense. The bending of light made sense. So nature looked at Newton's math and said, "Objection, that is the wrong map." And she looked at Einstein's math and said, "Sustained." So this tells us something important about our question. We invent the tools. We have a whole warehouse of mathematical tools: calculus, topology, group theory, chaos theory. Some of them are rusty, some are shiny. But we do not get to decide which ones work. We are like a mechanic who shows up to a broken engine. We try a wrench, it does not fit. We try a screwdriver, it slips. We try a hammer, bad idea. Finally, we reach for a weird, twisted little Allen key that we invented 10 years ago and forgot about, and click, it turns the bolt. So is math discovered. The need for the tool is discovered. The shape of the bolt is discovered. But the tool itself, that is something we forged in the fire of our own curiosity. But here's the thing that really gets me. Here is the cliffhanger. If we have all these tools in the warehouse, why is the universe built in such a way that any of our tools fit? Why is not the universe just chaos? Why is not it a mess that no logic can describe? We have these keys, but why is there a lock at all? Why does the universe obey rules that simple little human beings can understand? I want to take you a little deeper now, because there is something here that, well, it keeps me up at night. We have talked about math as a tool, a wrench, a map. That is all very sensible. But there is a point where the tool analogy breaks down and you are left with a mystery that is absolute. Let me tell you about the electron. Now, I spent a good part of my life working on a theory called quantum electrodynamics, or QED. It is the theory of how light and matter interact. It is a very strange theory. It involves particles popping in and out of existence, photons being exchanged, time going backward. It is a mess of crazy ideas. To make a prediction in QED, we have to draw these little pictures. We call them Feynman diagrams. We draw lines for electrons and these squiggles for photons, astros, and for every line and every squiggle, we write down a complex mathematical expression, integrals, probability, amplitude. We're just scribbling on paper. We are following rules we invented in 1948. Now, there is a specific number we calculate. It is called the magnetic moment of the electron, and basically how much like a magnet the electron is. It is a number called G. So the theorists, my friends and I, we sit down and we calculate. We calculate for years. We use computers now to do the integrals because they are so hard. And we get a number, a very precise number, 2.00231930 and so on. Then the experimentalists go into the basement. They do not look at our papers. They do not care about our integrals. They build a trap. They catch a single electron in a magnetic field, one solitary particle, and they keep it there for months. They tickle it with microwaves. They measure its frequency. They measure reality. And here's the thing that scares me. When they come up from the basement with their number, and we come out of our offices with our number, they agree. They do not just agree a little bit. They agree to 12 decimal places. 12. Do you know what that means? That is like measuring the distance from here to the moon and being accurate to within the width of a single human hair. Now, you have to ask yourself a very hard question. If mathematics is just a cultural construct, if it is just a game we invented like poetry or music, why does it predict the behavior of a physical particle to the width of a hair from the moon? We invented the integrals. We invented the vectors, but the electron obeys them. It is as if the universe is not just described by mathematics, but that the universe is mathematic. Galileo said it 400 years ago, the book of nature is written in the language of mathematics, but he did not know the half of it. He was looking at balls rolling down ramps. We are looking at the fundamental structure of reality, and at the bottom, we do not find stuff. We do not find solid little billiard balls. We find equations. We find probability waves. We find symmetries. We find numbers. It seems that the deeper we go, the less material the universe becomes, and the more mathematical it becomes. So here is the mystery. Why is the universe intelligible? Why can a monkey descended from the trees with a brain designed to find bananas understand the architecture of the cosmos? There is no logical reason for it. The universe could have been a chaotic mess. It could have been a static fuzz. It could have been governed by rules that change every Tuesday. But it is not. It is orderly. It is logical. It is beautiful. And it speaks our language, right? Or maybe we speak its language. Maybe the reason math works is that our brains are part of the universe, so the logic in here is the same as the logic out there. I do not know the answer. Nobody does. But it is the most beautiful riddle I have ever stared at. Now, because we have this mystery, the spooky connection between the scribbles in our notebooks and the movements of the stars, the philosophers have jumped in and they have been arguing about this for 2,000 years. They basically split into two camps, and you have to decide which camp you belong to. On the one side, you have the Platonists. They are named after Plato, the Greek fellow. They say, look, the reason math works so well is because mathematics is real. It exists. They believe there is let us call it a golden vault somewhere, a non-physical realm, a heaven for numbers. In this vault, there sits the perfect circle, not a circle drawn on a blackboard because that has chalk, dust, and bung, but the idea of a circle, perfect, eternal, unchanging. In this vault, you have the number pi. You have the square root of 2. You have the laws of calculus. They are sitting there waiting. When a mathematician proves a theorem, he is not inventing it. He is basically closing his eyes, reaching his mind into this golden vault and pulling out a truth that was already there. He is a discoverer. He is an explorer of this abstract world. To a Platonist, the universe is made of math. The physical world, the chairs, the atoms, the stars, is just a shadowy copy of the mathematical truth. Now, if that sounds very nice, it's very poetic, but there is another side. The pragmatists, the anti-realists, they say, do not be ridiculous. There is no golden vault. There is no heaven for numbers. Where is it? Can you measure it? Can you detect it with a Geiger counter? To them, mathematics is just a tool. It is a high-tech version of language. Think about the word rock. The word rock is not a rock. You cannot throw the word at a window and break it. The word is just a sound we make to describe the object. The pragmatist said, mathematics is just a language we invented to describe patterns. The universe has patterns. Things repeat, things fall, things spin, and we invented a language called calculus to talk about those patterns efficiently. If the math works, it is not because it is true in some mystical sense. It works because we kept fixing it until it fit. We are like tailors making a suit. If the sleeves are too long, we cut them. If the pants are too tight, we let them out. We tailored the math to fit the universe. So who is right? Is math the blueprint of God? Or is it just a really good user manual written by humans? I will tell you my view, and it is the view of a physicist, not a philosopher. It does not matter. I do not care if the number pi lives in a golden vault or inside my own head. I do not care if the wave function is a real thing or just a bookkeeping device. What I care about is, does it predict the experiment? If I use this math and I say the light will hit here and the light hits there, then the math is good. If it hits somewhere else, the math is bad. The miracle is not about where the math comes from. The miracle is that we have a method, a test called experiment. We can ask the universe, is this right? And the universe answers yes or no. So whether we discovered the math or invented it, the fact remains that it is the only way to talk to nature. It is the only language she understands. And that to me is more important than any philosophy. But that does not make the mystery go away. It just moves it. Because even if math is just a tool we invented, why is it the only tool that works? Why cannot we describe the universe with poetry? Why cannot we describe it with emotion? Why is the universe so strictly, rigidly, terrifyingly numerical? So where does that leave us? We started this hour asking a simple question. Is mathematics discovered or invented? And we found that the answer is a little bit of a cheat. It is both. We invent the concepts, we invent the symbols, we decide to call a circle a circle. We decide that parallel lines never meet. We act like the inventors of a game of chess. We make the board, we carve the pieces, we write the rule book. That part is human, that part is culture. But once we start playing the game, we discover the consequences. We discover that if we move the knight here and the bishop there, we get a checkmate. We did not invent the checkmate, it was hiding in the logic all along. And then the greatest surprise of all, we look up from our board, we look out at the stars, we look down at the atoms, and we see that the universe is playing the exact same game. The galaxies are following our ellipses, the electrons are following our complex numbers, the flowers are following our Fibonacci sequence. We invented a telescope, but we discovered the sky. Mathematics is that telescope. The true miracle, the thing that should make you dizzy, is not whether the math is inside our heads or outside in the world. The miracle is that the two seem to be connected. The miracle is that we, tiny, temporary, biological creatures stuck on a rock orbiting an average star, have managed to figure out a language that allows us to talk to the universe, and the universe answers back. Why? Why is the world intelligible? Why does nature follow logic? Why is the universe built in such a way that our minds can understand it? That is the deep question. That is the mystery that no one has solved. The answer is not in the back of the book. In fact, we have not even written that chapter yet. Maybe, just maybe, one of you will write it. Thank you.